And good afternoon, good evening, and welcome to episode 41 of Codebase Alpha. So, getting through these episodes now. So, I'm really pleased you could join me this evening. So, we're going to continue today with our synthesizer project and see what we can do about hooking up a MIDI controller to the project. So, I recently purchased this miniature MIDI keyboard. It's a very small, some 25 keys. So we're going to see if we can hook that up, and also we're going to wire up our delay effect, which I briefly demonstrated last time, I think. Before we start, there's a few things that we actually included in the project since the last stream. One of which was another pull request from FuelSnable, who very kindly helped me wire up all the drop-down menus, or the drop-down list that we started to kind of want to use into the T4 template. So it's really tidied the code up a bit and given us a bit more of a slimline XAML.cs file, which I'll show you in a second. So I'm not sure how long it's going to take us to get through what I've got kind of planned. So if we actually do finish it quite quickly, I'll also want to possibly show you a C++ framework called Juice. And we can use this framework to create audio plugins for digital audio workstations, and it's quite intriguing stuff. So I've only just started to scratch the surface of what we can do with that, and I'm not a C++ programmer. So just as I'm not a WPF programmer or a front-end programmer indeed, I'm also not a C++ programmer. So we should, if we do get that far, we'll have a bit of a laugh at me stumbling through some C++. Well, let's pop over into the code and have a look what's changed. Okay, so here we are in the main window view model, and one thing you immediately see is we've got these enums that have appeared. So these are for the drop-down menus or the drop-down lists that we created last time to tune your octave and your semitone for the voices, the extra voices we created. And you can see we've actually added now the option to go negative, so -1 and -2 octaves, and it's -11 to +11 semitones. And we are going to want to add cents to that, so we'll try and get that done today as well. If we go and look at our main window XAML CS file, you can see it's now slimline. So we're back really to just our two our key down and key up overrides here. There's a bit more code up in here, which I'll show you in a second. And then what else have we got? Over in the main window, model.cs again. What I've done is is basically changed the way that bass frequency works. So before it actually was working on an actual frequency. So bass frequency for A2 was 110 Hertz. A3 220 Hertz, A4 440 Hertz. But now what I've done is I've changed them to these integers, and these integers are basically based upon the MIDI keyboard. So these numbers are these notes on the MIDI keyboard. MIDI keyboard note values run up from 0 to 127. So that's more than a piano. So as you can see, kind of a fairly low A here is key number 33 in a MIDI. So we've converted to that. The default will be in the key 33, and we've got a MIDI enabled flag now, and doesn't do anything yet. But basically, what happens if MIDI is enabled, we're going to bail out of our key up and key down methods, and we're going to do some refactoring in here. What else have we got? I think that's basically it. There's a bit of UI work that we did as well. So if I go over to the main window.xaml file, we'll see if we can see that. So hopefully we'll get a picture here. Okay, so what we got now is down next to the on-off button, there's a drop-down list which will be populated by any MIDI controllers that you've got plugged in, and then we've got a MIDI on and a MIDI off button. Now what happens then is over in the CS, the code behind this XAML, you can see that we look through the we use this class MIDI in, which is part of N audio, to go searching through the number of devices we've got, from MIDI in devices we've got, and then we add them to a collection, which is the what we display in the drop down list. And then if we've got any MIDI devices at all, and we select the first one as the default one, otherwise we actually hide all those controls. So we hide the MIDI in devices, the label, and the on and off button, and we set the MIDI enabled flag to false. So if I run this up now, we should actually find that because I've got a MIDI controller attached, Remnant Geek, welcome to the stream, good to see you. Because I have got a MIDI controller attached, then we've got, this is the LPK25, which is my Akai mini MIDI controller I've got here, and the MIDI on and off are actually visible. But they don't do anything yet, so we need to kind of wire those up. Pure Snable, welcome to the stream. You've been considered using visual styling in WFF to make the UI more looking like a synthesizer. Yes, it'd be nice to have like these proper knobs, wouldn't it? You know, these sliders like proper faders and the controls looking, and maybe that kind of metallic sheen to it. Cody Beard, welcome to the stream. Good to see you. So yeah, it would really be nice to be able to do that. But I'd say it's not a primary thing. So if we're just going to go over what we've got so far, we've now got the three voices. So a main voice here with all the controls on. Voice 2, we've got its own amplitude envelope control. So each of them have got a separate one. Obviously a different waveform selector, and then we've got a level, and then we've got the tuning here. Which we need to label up and smarten up a bit, but there's a big kind of empty space here, which I'm not sure what we're going to fill with, but we'll probably figure something. And exactly the same for voice 3, you can see. So we can choose different waveforms. On the main voice, we've got our usual. That's nice and low. Then we've changed these selectors now to be these drop-down boxes rather than radio buttons. And then we can mix in. I don't know, put a square wave, 50%, 1 octave higher. And you can see that on the frequency analyzer at the top there, we get the fundamentals, and we also get a bit of some overtones coming in, which because of the square wave, producing lots of high frequencies. So that's looking pretty good. But controlling it through the computer keyboard, obviously, we've only got 16 keys, and it's a bit kind of, you have to fiddle around. I keep pressing the wrong keys as well. You haven't got an awful lot of room, so I thought we could try wiring up this MIDI keyboard. Pure Snowball is saying that you can make WF visualize a drop down as radio buttons with visual styling. Right, okay. The behavior of the controls independent of the visual. Yeah, which is a big advantage of WF, I guess. But you see, it'd be really nice to have, as you say, that kind of vintage, synthesizer appearance, especially if you had kind of patch cables. Brilliant, so like an old Moog or something like that. I'm going to do an on-screen keyboard. Yeah, we could do an on-screen keyboard, but it's not as good as having a real keyboard. So, and playing with the mouse is you're never going to be able to play chords very easily with a mouse. So it's a bit kind of. There's not an awful lot of value in doing that when we can play with a computer keyboard or with a proper MIDI keyboard. So people that are following along who haven't got these devices can still have a play with the synthesizer project. But if you do have a MIDI controller available, they plug one in and play around. So okay, so let's see what we need to do to actually get this working. So I guess we're going to need a MIDI in device. So over here we're going to need a private variable, which is going to be our MIDI in. So private MIDI in. Let's control .lat and see if we can bring that in. Yeah, get the MIDI portion of N audio in here, and that's going to be MIDI in. Okay. So let's go and see what the documentation for N-Audio has got to do to help us. So let's pop over there. So here's the GitHub page for N-Audio, and down, so if we scroll down, there's a description of the bits and pieces in here, and you can see it's got a full MIDI event model, and it's got the ability to respond to MIDI events, which is what we want to do. And if we actually scroll a bit further down, there's what it's calling tutorials. They're not really not tutorials, really, it's a bit of documentation. And we've got sending and receiving MIDI events. Let's go and have a look at what that's got to say. So here's receiving MIDI events. So to start monitoring MIDI messages, we create a new instance of MIDI in, pass the selected device index in, and when we subscribe to these message received and error received properties, then we call start. Okay, so let's grab this code and we'll pop over to here. Now we've got commands set up now for MIDI on and MIDI off. So here's MIDI on. So it's setting the MIDI enable to true. So we need to actually then create our MIDI device, and selected MIDI index. So that's going to be set over here. So MIDI in devices dot selected index is going to be what we want there. Let's see if that's actually visible to us. On this control, probably not. Oh, no, it's not. The MIDI in devices dot. So we're going to need to pass that in, aren't we? So let's do that. Let's have a new property here. So this is going to be an integer property, and it's being called selected MIDI device. Okay, set that, and we'll default that to -1. And then over in here we can we can set that, so it'll be view model is going to be equal to that, and we'll need to have an event on there where it changes. So what's this selected index is an integer, so this has got to be selected MIDI device. We're going to need to cater the fact when we change that, but currently I only have one MIDI device anyway, so we'll gloss over that just for now. Pure Snowball, you're waiting for Apple to abandon keyboard on MacBook Pro for a full touch bar keyboard. Yeah. Well, they've abandoned everything else, haven't they? I think there would be it were awful, but it seems like a logical next step. I think maybe thought control. Yeah. Yeah, everything's wireless. Those wireless earbuds, I see people on the train with them, and I don't know about you, but when I put my wired earbuds from my iPod into my ears, they invariably fall out every now and again. So I don't know if I'm not wearing them correctly, or if those wireless earbuds kind of, if they wedge in really kind of tightly. But I'd be really frightened of walking along and dropping those and not noticing, especially on a busy train. So yeah. Okay. So let's go down here and set that up. That's a selected device. We'll not worry about that one just yet. So let's create this MIDI and message received. So we're going to change the name, I think. Okay, let's see what else they want to do with it. So they're just okay. We'll just pinch the code again, and we'll change the name, I think. So let's put it up near the key up, key down. We'll call this MIDI message received. We don't want to log. And we'll wire that up like that, and this will be a MIDI error when we come to implement it. MIDI error received. Okay. So we call start and then set can execute, and then when we switch off, then we want to do MIDI in dot stop, and I think we need to dispose it. Let's have a look. Let's see what it says over here. Yeah, stop and then dispose. MIDI in dot dispose. Okay. So now we're kind of switching on and off there. We got a MIDI events being generated at that point. So I guess what we need to do is figure out what kind of things come to us in a MIDI message received. So let's just say this is going to be equal to the MIDI event, and then see what we get when we press. Oops, don't want that. That's code places. Go away, code places. Thank you. So let's place a breakpoint there. Let's start up the synth. So Fuel Stable says, we talked about our interns. I found a really neat project for them to do. Well, what was that? Traffic generation. To generate test traffic for our system. Is that kind of network traffic or actual data flows? Let's switch this on. Let's switch MIDI on. And I'm going to press a key on the keyboard. I'm going to press this one here. So we've hit our MIDI event, and we've hit kind of C5, which is middle C on my keyboard. So what have I got? I've got note on, which is the command code, which is what we note on and note off are what we're interested in. We've got C5 was the note that was pressed, and we got a velocity of 80. So velocity is how hard I press the key. So we're actually, by implementing the MIDI keyboard, we're getting at some kind of touch sensitivity. So we're going to manipulate the amplitude of our wave that we create according to how vigorous we are on the keyboard. So that was a reasonably hard stab, and that was 80, and that's a number between 0 and 127 as well. So it's a bit disappointing that we've got C5 as note number 60. There we go, note number 60, which is what we want. So I'm just going to grab a pencil. There we go. Okay, so we've got, I'm going to just jot down what those values are. So we've got note number, and we've got command code, and we've got velocity. Those are pretty much what we're going to need at the moment. The rest of it, they were all kind of 0. Channel 1. Okay, we're mono, so that's why it's channel 1, I guess. That should be enough for now. We've got an off event as well. Okay, so let's stop there. So what we're going to need to do is to figure out what our MIDI event was. So So let's see what we've got on here. So we've got command code, and if I copy this and I Control C into the paste buffer and I type that, I should get a switch statement. So we got all of them there. So note on and note off. There's aftertouch. There's whole loads of things which we can do. So we'll leave that as a full list of all the different values of MIDI command code. We're only interested really at the moment in note off and note on, but we may be interested in things like aftertouch. So we haven't got a pitch wheel, so that's not going to be of any use to us. There's other things on here as well, so the sequencing and other things. But we'll leave those set there. Fuel enable. In addition, there are so-called funnel analysis and session generation that we could do, that traffic generation could simulate. It certainly seems an interesting project for them to do. And the thing is, it's interesting to them but useful to you, which is the kind of golden combination. It's no good having interns in and giving them projects which are either tedious for them and not going to learn from, and or which aren't of any use to your company, because they're there to not only just to for, I don't know is it 6 weeks they're with you or 6 months? I can't remember how long you said Fuel Stable, but it's that kind of a long interview for them. But they need to get something out of that kind of experience, I think, and so does the company. You don't want to be they don't want to be twiddling their thumbs. You don't want them kind of not contributing to the business in any kind of meaningful way. Those things like test harnesses is a brilliant thing to do. Okay, so now we've got our switch statement that's been generated for us. So note on and note off. So this is going to be the equivalent of key up and key down. So we now need to do something similar to this, don't we? So we can pull all this code out, I believe, into a method. So let's think about this. So we've got 25 notes, 25 keys on our keyboard, so we're going to have to increase the size of our array anyway. So obviously this is not going to work so great if you've got a bigger MIDI controller, but we'll so a piano keyboard has got 80 keys, is that right? So let's figure out how many keys there are. How many keys on a piano? 88 keys. So what we'll do is we'll size it to be 88, and that'll be kind of as much, because you're not going to get anything bigger than that, I don't think, on a MIDI controller. So Fuel Stable says yes, that's important. About the interns, yeah, we want a project they feel important for them, but they think is meaningful, but also small and limited enough for someone to grasp in a few days. And also, if they don't finish it, it would be a bit of a shame. So something they can complete in the time that are going to be with you. So list key is no longer of interest to us at this stage. So we're going to make this 88. Like that. Okay. Most of the time we won't be using 88 slots, so that'll be fine, because it's only containing a reference. So where are we? Here we are. So key up, key down. So let's grab this lot. And let's extract it into a method. method. We'll call it note on, shall we? Okay. I'm going to move this key val and MIDI key val. Okay. Let's cut that and move it. Oops. Let's move it out of the way down the bottom here. We're missing a closing brace. There we go. So that should be fine. So note on, we want to run note on, and it's going to be MIDI event dot, and it was note number. Where's note number gone? Interesting. Where's note number gone? I'm sure we had. That, didn't I? I noted it down. We also haven't got velocity on there. Was it a note on event, wasn't it? So note on. Okay, well let's do that again. Let's figure out what's going on there. Synthesizer on. Switch on. MIDI on. Press there. So MIDI event. Well, it's there, isn't it? Adron, welcome to the stream. Good to see you. Yeah, it's going pretty good with the code. I'm just interested that my MIDI event here. MIDI event. I've got properties here which don't appear to be available to me. What's in raw message is no good to us. MIDI event should have note number and velocity. Oh, weird. So MIDI note on e dot MIDI event dot. Where is it? Note number. Oh, it's there. Oh no, it's not. Does not contain a definition of note number. Am I missing a type? Interesting. I don't understand that. I wonder if this MIDI event is coming from somewhere else. N-audio MIDI event args. E dot. Raw message. That's nothing too interesting there, I don't think. E dot. MIDI event dot. I'm slightly confused. Let's go back over here and see what N-Audio's got to say about it. So they're just he's just printing out the MIDI events. So there's a MIDI in message event args, timestamp in milliseconds, a MIDI event as well as a raw MIDI event, which we're not interested in. So why can't I get note number? Okay. Let's have a look. N-Audio MIDI events. Oh, so we need to cast it to a note on event. Okay, well that's makes all the difference. So var note on event is equal to a note on event of e dot MIDI events, and then we're going to want that's a note on event, and then we're going to want to call that note on. So note on, and it's going to be note on event dot note number, and then it's going to be the same again. Like that. And we need to then do something with velocity, but we'll leave that for the moment. Key down. Is that, and then key up. Let's move key up. Shall we? Let's move it next to key down. Okay, key up. So again, we're doing basically the same kind of thing. We're just stopping, aren't we? So let's just extract that out as well. Note off. That'll be enough. So this is simply going to be same kind of idea. We can just copy this piece of code up here. And this will be notes off, but we don't need to pass in the note number twice this time. Note off event. This is a note off. And that's a note off. Got the note number. Isn't there a note off event? It's the off event of the note on. Okay. Okay, I don't. We need. To, we haven't got this. Haven't quite got this figured out. I don't think so. This is the note on event. Note off. We'll call it a note off event. It's a note on event. .mini event dot. So it's a MIDI on event note number, but we need to make sure we're switching the note off. Note off events. Okay, we need to figure out what goes on in this case, don't we? So let's pop a breakpoint there. Put the synthesizer on. Put the MIDI on, and then I'll press middle C again. Now that's off. So we've hit here. Note off event is null at the moment. Let's step over that. Oh, didn't I hit my breakpoint? Let's try again. On, MIDI on. We've hit it. It's got note off. So the MIDI event. The MIDI event. The command code is note off. So we've hit there. So we know the note is going off, and there is a note number there. So we should just pass the note number in, shouldn't we? If we step over, we didn't seem to hit this, did we? Let's see what happens if we just try and play. Bing, and that on. Oh, we've got an invalid cast. That's what's causing the problem. That's why we're not hitting it. So let's see what happens now. So let's pop a breakpoint there. Let's in fact just comment that out. Pop a breakpoint on the break statement, and then see what we see. So this is all very interesting. Let's press so we hit our note off event. So this MIDI event is a note off, and it's got a note number on it. But we figured last time it didn't actually tell us that. We need to cast it to something. So it's MIDI event.note off. Do you think? No, not. The note off event contains a note number. Why can't we just use the note number? What's it say over here? If it's note on, you don't need to handle note off events yourself. However, the tempo might change between note on and note off events. So any audio calculates it for me. Not quite what I wanted. It's not quite what I want, is it? So all I want is the note number out of that. That's all I want. It's going to say note number is not available to me, isn't it? Does not contain a definition for note number. in here they're saying note off event is T note, the off event. I don't want to know the length though in audio. I just want a on and off event, just like just in pure MIDI. Get this notes. So let's get the note on events or not. Understand? If I look in both events, note on off, I'll get duplicate notes. How do I get notes time? Note as a separate note on and note off. It already searches for the corresponding note off event and calculates the length for you, so you don't need to handle the note off events yourself. However, the tempo might change between note on and note off events. You have to compute the time separately. Wally Dom, thank you very much for the follow. That's very kind of you. Let's have a bit of Electric Alf to celebrate that follow. So thank you so much. Here's Pure Snable's Electric Alf WebGL shader. So thank you very much for the follow. So I'm kind of struggling here because and what on the face of it is a simple requirement to know when a note on event is pressed and the note off event is pressed. It seems that NLaudio is trying to hide that from me. So let's go and have a look at the source code for this. NLaudio MIDI event. Note event. A note event. What's that? Can I cast it as a note event? If I do that, what happens? I'll get a note number. Okay, well let's place a breakpoint there and run that. Cheers everybody. Okay, MIDI on. Let's press middle C again. So hit there, key 60. Okay, well, that looks a bit promising. So let's go back and see if we can play. And that's all coming from the MIDI keyboard. So that's pretty good. So I'll just if I can hold this up and you can see that when I press. So we've got our basic MIDI events working. Right, thank you for the kind words. Yeah, so we're quite well into this project at the moment, and it's looking pretty good. We certainly got a good variety of sounds that the synthesizer makes now. I'll do some demonstrations once we got the rest of this wired up, so people who haven't seen it before can see the kind of sounds we can get out of the synthesizer. And we've got a new DSP effect to actually add today, at least the GUI part of it to add in. So aftertouch. We'll look at aftertouch at some point. So what I'm interested in doing next is the velocity. So we need to kind of modify, depending on how hard you press the key, we need to modify the amplitude of the signal that's generated. And that's going to be on the note on. So let's go over to note on. We're going to have an int velocity, and we're going to default that to we'll make it a float. We're going to default that to 1. And then we want to multiply we want to multiply the level by that. So this is going to be velocity times the level. Let's put that in each of those. A bit of a delay there. Like that. And then what we can do is pass in there, when we do our MIDI work, which is here, we can get var velocity is going to be equal to the note on events dot velocity divided by 127, like that. That should give us a floating point number, single. Fine. We'll pass the velocity in like that. So that should give us touch sensitivity. So let's try that out. MIDI on. So I'm going to turn the volume. So we're going to disregard these volume sliders. They're not right, but we'll turn it to 50%. And so I'll hit middle C kind of gently. So we got some touch sensitivity there. Sorry about the noise. Let's see if we can play a proper chord, shall we? Yeah, it's a bit racket, isn't it? So let's have a fiddle. Yeah, so it's not going to work with these octaves. We need to hide that. So I've got an octave up and down buttons on my keyboard. So let's there's that. Let's do octave up. Let's octave down. Octave up. Come on. That's very low now. And then we just blew it out there. Key 96, yeah. So we need to make sure this is within range now, don't we? So key 88 is the highest we're going to go to, which is very, very high. So let's make sure that it's greater than that, and key val is less than or equal to 88, just so we don't get that problem. So let's try that again. Yeah, we're not making the sound now, so I'm going to turn it on, that's why. And then we hit there. So that's the note off. We need to protect note off as well, so we'll do that as well. Key val less than or equal to 88. Okay. I'm reasonably happy with that. That's our touch sensitivity. So we got some aftertouch, and so I'm just going to look up aftertouch and see what the implications of aftertouch are. And we might not deal with it today, but MIDI aftertouch. We might have to think about what is aftertouch. We might need to think about what the implications of it are. So aftertouch is the MIDI data event saying when pressure is applied to the keyboard after the key has been struck while it is being held down. It's often routed to control vibrato. Okay, so that's some kind of variation Okay. The pressure applied to the keyboard after the key has been struck, while it is being held down or sustained. The aftertouch is often routed to control vibrato, volume, and other parameters. Channel aftertouch. This looks at the keys being held and transmit only the highest aftertouch value amongst them. Less common is polyphonic aftertouch, which allows each key being held to transmit a separate independent touch value. I'm not sure what to do with it. That's the problem. We need to control. We could try and control vibrato with it, I suppose. Oh, well done. The font confused you. Wondered what the symbol was before you explained it was a greater. Oh, okay. Yeah, it's Code is the font. You can use Chocolatey to download it, and if you install it as your font in Visual Studio, you get the ligatures like that. So you get I don't know if you notice, if we go down to here, this is kind of, it's not one letter, but it's been kind of, those have been elided together, and then you get the mathematical symbols. And not equals is equals with a slash through it. And if you're using something like F sharp, then you get nice the kind of pipe operators are triangles, so it does look quite nice. And I think when we did some work with Fuel Stable on F sharp parser combinators, the bind operator looked really nice. It was let's see if I can get it to appear actually. It was that. So that's the bind operator. You can see it's quite a nice explanation actually what bind does in a visual kind of format. So I really do like Code. Do recommend it. It's great. Okay, so we've got it's got key aftertouch and channel aftertouch. I don't know what if we generate any aftertouch figures. Let's drop a breakpoint here, and I'll try some aftertouch. We'll drop a breakpoint in there, key aftertouch, and see if we get anything. And then I'll have a think about it, see how it's gonna affect what the sound we make. Have we hit the breakpoint already? Interesting. Oh, it's so high, that's the problem. My keyboard has remembered what it that it's an extremely high frequency. Let's bring the, there we go. We're not getting any key aftertouch. Let's try some channel aftertouch. I don't think we get any of that. I think my keyboard's not generating those, I don't think. So let's just pop a breakpoint there. So there's no aftertouch in there. Yeah, so I'm either not generating those values, or N-Audio is not picking those values up. So a lot of this is going to be kind of pretty useless to us. Note on and off is all we really need. Okay. What's that? What's happened there? What's this? Oh, weird. Okay. Okay, so let's go over to our issue list. Over here, issues, and we can now play our synthesizer using a MIDI controller. Okay, set up the synth to react to note on and note off. Events with velocity, sensitivity, sensitivity. So we can now close that. And we may come back to adding some more features to that if we can figure out how to do it. That's that one. So there's two more things that I wanted to look at. The first one was going to be the echo effect, the delay. But I think switching our volume and gain sliders to using decibels is probably something we can do very quickly. So the reason why we want to do this, if I actually demonstrate it, switch the synthesizer on, and I'll just use the keyboard rather than MIDI control for this. So currently our volume, we'll put our volume right down to 0. So if I hit the note A, now let's just bring it up for one octave. So there's note A. Obviously you get nothing. So if we start to increase the volume, it's getting quite loud even with 11%. But I don't know if you notice, to our perception, even though the amplitude's increasing, there's an awful lot more difference to our hearing by waggling the volume slider down here in this area than there is in this area. It almost sounds the same volume, and this is because the human ear doesn't hear volume or amplitude of pressure waves in a linear fashion. It responds in a logarithmic way. So that's why when on professional audio equipment you don't have percentages or 1 to 11 to quote Spinal Tap. You actually have decibels which go from negative infinity usually to 0 or at most +6 or +12 if they're going to boost the signal. And we want our sliders to react, our gain sliders to react logarithmically. So this is obviously a gain slider, our master volume, and then we've got level sliders here on the voices, and we've also got a gain here. So I think if we make these logarithmic, at least the volume sliders logarithmic, it's going to be a bit kind of more natural that we get our hearing will pick up this as a more linear. We'll perceive it as being a more linear increase in volume, but in fact it's going to be logarithmic because that's how the human ear works. So let's tackle the master volume slider first. So should we do a bit of maths? It's not difficult maths. So let's colour this in grey. Okay. Have a pencil and make it fairly thick. Okay. So what's the definition of a decibel? So it's a bit with decibels. They're not an absolute value. Okay, they're a comparison between two values. Like a percentage isn't a thing. It's a comparison between two things. Decibels are the same. It's a comparison between two levels. And what we say, we define that the natural loudest sound, amplitude of 1, is 0 decibels. So we're going to run from 0, and then our scale is going to go down in a logarithmic fashion, and it actually ends at minus infinity. Negative infinity is complete silence. We find that 50% volume is about minus 6 decibels. I could write decibels. And then so it kind of scans through in that fashion. So a decibel is defined as being 20 times the log to the base 10 of x, where x is a number between well, in this case, it's going to be a number between 1 and 0, because that's the range that we're trying to convert from. So we have to solve this for x now. To solve that for x is relatively simple. So x is going to be equal 10 to the power of decibels over 20. So if we convert our range sliders, our sliders to actually give this figure, that's going to be the kind of, so we're going to go say from 0 to say minus, I don't know, minus 48. Pretty quiet. Then this, so say at 0, this is going to be 0, so this is going to be 0, so this will be value of 1, and x will be 1. So remember, anything to the power 0 is 1. And when this is minus 48, it's going to be 10 to the power of minus 2.4, which is going to be a small number, which effectively is going to be silence for us, or very, very quiet. So so this is the kind of formula that we want to use to the conversions. But usually it's going to be quite simple to do that. So let's go over to our main window first and find the master volume slider, which is here. In fact, we were going to call it master volume. We'll change it now, because it is the volume, the overall volume, because we're passing our all our feeds, all our notes and sounds are going into a mixer, and then we've got the volume control on the output of the mixer. So it is controlling the overall volume. So it is the master volume, and the slider span currently is between 1 and 0. So if we change this between 0.0 and minus 48.0, 48.0, and if we can change the step of that. So what's the we'll leave the stepping alone at the moment. Let's see what it looks like. It's minus 48 now. Okay, so then back over here, I'll just check our T4 template. We need to change that, because the volume here is an integer now in a percentage. So this is going to be between 0.0 and minus 48. This needs to read decibels, and we want to have let's start off by not altering it at all and see what it looks like. Regenerate that, and then we'll go over to our model here, and we want the unchanged changed volume. Then our volume control is going to be equal to this. So this is going to be, rather than that, the current value. It's going to be so math.pow 10 it's going to be that. So 10 to the power of whatever the output of our slider is divided by 20. So let's see if that actually A works and B looks any good. So we're up at far too loud, so but that actually looks okay. It's we need to make that label a bit bigger, but it's actually far too loud. I'll blow our eardrums, or blow my speakers. So let's go and fiddle with those values. So the value it's the label we want to change. We'll make it 50 wide. That should take care of the dB symbol. And then over in our main model, our volume, rather than being 0.25, is going to be -15. And we'll just put a comment, say that's decibels. Decibels sound pressure level, if you want the full kind of technical kind of description of what the decibels. There's different types of decibels, including kind of voltage decibels or whatever. Okay, let's have a look at that again. So we need to, hopefully it'll start at a reasonably quiet position. So that's where it is. Let's switch it on. Let's play. So now, if I bring it right the way down here, it'll be very quiet. In fact, I bring it all the way down, you'll still get some volume. But now, if I move it, if I hold down C and I move it up, we should see even the amplitude is not reacting linearly to our ears. That is a smooth transition. We're getting some artifacts. You can hear I don't know if you can hear the clicks. It's because I'm changing the volume as I'm sliding, and it's the algorithm we got hasn't got any kind of smoothing of the parameter. So the parameter's changing while I'm still playing the keyboard. You're getting some clicks as it kind of resets itself. So, but we're not really worried about that. That's a bit of a feature we could put into our synth, but we're kind of pushing our luck with this synthesizer. Really, remember, this is not C#, and we're not computationally kind of working it flat out. It just happened to have a powerful PC. This is C# doing all this. Garbage collections going on in the background, which is a bad thing to be happening while you're trying to play a musical instrument. So it's pretty good performance. I'm pretty impressed. I mean, yeah, I've got a meaty PC, but you know, it's pretty impressive for C# to be doing this. I'm very, very pleased with the performance of it. So we've now got our master volume working in decibels. So let's convert all the level sliders to decibels as well. This is going to be these levels here. So we're going to have these at -48. And this one at -15. It was 100, wasn't it? So that's going to be at 0. This is relative now. This is that's just means full volume for that particular level. Obviously, we're still then multiplying by our master volume, which is why I say that the master volume is controlling the overall gain of the system. If you're Noble, C# needs a no-op garbage collector. Yeah, maybe you could just switch it off. Yeah, we're not suffering from garbage collection. I mean, if I was a musician and I played this properly, maybe we would kind of have more difficulty with it, because I'm just kind of stabbing some keys and making pretty sounds, and that's really the object of the exercise. It wasn't really to make a full-blown musical instrument. But when we start to look a bit in a few streams time, or maybe even start tonight, depending how we get on, look at doing kind of proper audio plugins for professional software, then being, you know, as fast as we possibly can is going to be really, really important, because you can have whole chains of real-time digital signal processing plugins kind of working on a signal chain, and you've got to be quick, and no latency, at least not any unintentional latency. Obviously, we can introduce latency on purpose as part of a delay. But yeah, it's going to become more important so that we have better performance, which is why I'm looking to do a bit of C++ and look at what that's got to offer us in terms of doing some digital audio stuff. Yes, so a jitter plus garbage collection. Yeah, it's not good for latency, feel stable, and you know, that's why I'm, you know, I'm pretty chuffed, to be honest, that it actually works as well as it does. We're doing a lot of construction of objects and then disposing of them. We've got a long signal chain now. We're going to make it a bit longer tonight. So yeah, it's pretty impressive, if I say so myself. Okay, let's go over to find our level controls. So here's the level here. So here we are. So this is going to be a maximum of 0 and a minimum of -48 again. And the tick frequency is going to be 1.0. That's level 1. And this probably needs to be 50 as well, doesn't it? And then we go to the other ones. So we got level 2 somewhere down here. That's the phaser. Level 2, so that's going to be 0 to -48 again. And that's going to be 1, 0. And we need to increase the width of that label there, didn't we? 50. And then finally down here somewhere we've got level 3, so this is going to be once again 0 to -48. That's going to be 1, and then that's going to be 50. So that should be that, and then back over here we should have our level 1, 2 and 3 change. Where are they? Oh, they're probably actually in the note on. Yes, so they're here. So we're going to need to calculate those as well. So we need to normalize this. So var so gain, we'll call it gain. Gain 1 is equal to so then we said it was math.pow 10.0, and then it'll be level divided by 20. And what's that going to give me? Is that going to be a float? That's a double, so we'll just make them to a float. And then it'll be gain 1 over here instead. We can just work out all of those. Gain 2, 3. And we might as well multiply it by the volume, by the velocity here. That. Gain 2. And finally gain 3. Okay, let's try that out. Don't forget WPF, it's pretty intense at creating objects. Yes, I've noticed that. If we go and have a look at Field Snowball, we can see how much memory is being used at the moment. So we're not doing anything yet. We're not creating any objects from pressing keys, and we're already at 95, 96 now. And you can see that when this yellow blob here shows when we get some garbage collection. So we'll just leave that showing. We already jumped up. Like all I did was move the adjust the window. Look at this. Yeah, so it's pretty intense, isn't it? Let's switch on. We've got a level here. We haven't changed the label, unfortunately, so we need to figure that. So let's do those, because also we need to make sure the label fits in okay. That's picking out our generation here. So level 1, level 2, level 3 are here, so we can now get rid of this multiplication. Right, that. And I love T4 templates, how they're working with this project. It is so nice to work with. Okay, let's tidy up. I don't know why I'm being a bit OCD about these lining up, but I do like to see them line up. We'll generate that, and we should be able to run again. Okay, so we're at decibels now, and yeah, down to -48. John, we'll have that A3. We'll put this up to, I don't know, -15 decibels, an octave above, and that'll be a square wave. And then this one here, -20 decibels, 2 octaves above, and it'll be a, I don't know, sawtooth wave. Okay, that seems to be working okay. Let's try and recreate the bell sound we had last time. So let's set that up. That's going to be a sine wave as well. Let's bump that up. Then we had a short attack, delay, sustain right down, and a long release for our envelope, and we'll do a similar kind of thing for these. Release and I don't know. Like that, perhaps. That's our bell sound. So, what else can we do? We can put some vibrato on that. I think if we overdrive the amplitude modulation, that probably causes something interesting to happen. Bit of ring modulation. Yeah, that's quite nice. So if we put some chorus on as well, let's get all the effects going. So it really is like bells. We can put all kinds of things on. Let's stick some phaser on as well. Bit of feedback, frequency up to 100. Sweep it around. A bit like maybe that's kind of steel drum. Do you think? Yeah, it's like a steel drum. If I could play the instrument, that'd be. That's what they do. They kind of do a bit of tremolo on that, don't they? There we go. So that's how we've got another gain slider here. Yeah, not sure about that one. Okay, let's stop. Let's go and have a look at. Let's do a bit of GUI work then. So we'll go and mark that. Change the level and gain sliders to dB as done. And I might come back and do that other gain slider at some point. Okay. So one of the things I did off stream was to build a because it was a bit maths heavy, and I realised that when we did the phaser, we did a reasonable amount of mathematics on stream, and when I get into doing some digital signal processing plugins, it's going to be a bit more maths. I'll show you what my latest purchase is. This weighty tome. It's probably backwards on the screen, isn't it? It's actually designing audio effect plugins in C++ with DSP theory, and it's got yeah. So you've heard of differential equations. This is full of what they call difference equations. So differential equations are they live in the analog world, and the digital equivalent of a differential equation is called a difference equation because it's using kind of quantized discrete values, not continuous values. And they're quite complicated. They use complex numbers, so they're working in the complex plane because that's the way sound actually works. It's not. It has the real and the imaginary kind of components. So yeah, so I'm going to have to do a lot of reading and background work before we can kind of tackle anything difficult on that side. So we're going to look at this Echo. So I built the Echo sample provider. What we need to do is wire up the GUI so we can actually play around with the effects, because at the moment it's kind of fixed. The event is fixed. So let's go and have a look at that. So if we go over to the delay sample provider, there's a number of parameters that we set. So these are the main parameters. There's a delay in milliseconds. There's a feedback percentage. There's a gain on the mix, and then there's the wet and the dry. Remember, the dry signal is unprocessed, and the wet signal has been processed by our digital signal processing package. So that's the dry is unaffected, and the wet is the one that's been through the delay. So it's the delayed signals. And the actual processing is relatively straightforward, represented by this equation here. But in fact, where the complexity comes in is actually where we slide the response around. So we slide the delay around according to the time delay we want to build into it. And basically, this is the way it works. Is we have a big buffer, and we write some of the samples off into the buffer, then read them off later in the time frame of the samples, so that they appear to echo. So that they play, and then in this case, you will hear a note, for example, or a sample will sound, and then 300 milliseconds later, that'll sound again, and then another 300 milliseconds later, it'll sound again, but quieter, so the echoes die away. So you see echo, 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 that kind of idea. So we've got 5 values. I'm just going to make a note of what those values are on my notes here. So we've got delay in milliseconds. Then we've got feedback. That's going to be in decibels. The mix is going to be in decibels. Currently, as you can see, it's not. It's in. Yeah, we've got to be a bit careful with feedback. We've got a couple of effects now which do involve feedback, and if you feedback too much, then it's just like an analog component. If you've got some electronics and the feedback hits a certain point, then they start oscillating. So it's like when Jimi Hendrix holds his guitar near to the loudspeakers and it starts to screech. It's self-oscillating, and we will get that here, even with digital. We're dealing with ones and zeros here, and we still get that effect. We get the screech of the feedback, and it could, get very, very loud. So what we don't want to do is to have full feedback. So we need to work out what the range there is. It's going to be minus 48. That's again, or minus 60 perhaps. But what we might leave feedback in percentage just to start with when we get it work. There we're going to have the amount of dry signals to feed into the delay effect, and then the wet mix and the dry mix when we mix them back together again. Okay, so these are the values we want. So there's mix, and then there's wet and dry. Okay, so let's go and set that up in our window. We pretty much run out of space on here, so we're going to need to create some more space. Yeah. So we want some more space down the bottom there, I think. So we want 3 rows. What row is that? That's that row there, isn't it? So we want basically that again. Let's just try that. Let's add 3 more rows to that. For some reason our spacing goes a little bit weird. I think Fuel Snubber, you fell foul of the editor wanting to reformat everything. And copy these down to there. Well, actually, that's not right, is it? That's not exactly what I wanted. What I want is, let's wind that back. That's not quite correct. Let's get it right up here first. So I don't want to insert those. So let's think. So this row here, where the buttons are, that is 0, 1, 2, 3, 4, 5, 6, 7, 8. Is that row 8? Where the buttons are. It's row 7. Zero, 1, 2, 3, 4, 5, 6, 7. That's that row there. So we want to put these in above that. Like that. And then that button row becomes row 10. Good, row 10. Yeah, that looks okay. And we need to make it taller. So height of 1000. It's too much. 900. Yeah, 900 is okay. So we copy the whole of that now, so we don't make any mistakes with the rest of it. And down here, that's going to be that, and the button row is going to be row 10. Yep. And then here it's going to be the same. And the button row will be row 10 again. And then we better pop back up the top here. For this, that looks like that's all in the same row, so that's good. Okay. So we've got 3 rows in here. So let's go to this position here. So we want a stat panel. That's row 6. So we want a stat panel in row 7. There's the tremolo. There's the phaser. And there's the, so we'll have a stat panel in here. This is going to doesn't need a name. It's going to be horizontal. It's going to be in grid row. It's going to be 7, and column is going to be column 1. That's that stat panel, and then we're going to want stat panels in 8 and 9. Get this to line up nicely. The reason I'm not using there's a kind of document reformat, and I've used that before, and it's had some really weird effects. So I'm gonna kind of tidy the layout up by hand, for at least for while we're on stream, so I don't kind of get into a situation where all I'm doing is trying to recreate this layout. You think you'd have used more stat panels than one big grid? Yeah, possibly. Yeah, we could probably, yeah, okay, stat panels within stat panels, but I'll stick with the grids for the stat panels for the moment, because say I'm still learning WPF, so kind of sticking with things I understand is probably a good idea at this stage. So we're going to want to fit 5 sliders in here, and 5 sliders, we get 4 sliders in, okay, but 5 sliders we won't get in. So let's col span it. Grid column span 2, and see what that does. Like that, okay. So we got 4 sliders in there in the envelope, so let's go and just pinch those sliders. There they are. There's the labels. We'll grab those labels. Go down here. That's there. No, that's not where we wanted, is it? That's not where they needed to go. And let's move them into the right position. Those go down here. A bit annoyed with this layout. And we want another label here. So let's bind these to some values. So we got delay, delay milliseconds label. And then we've got a feedback. So it's going to be delay feedback. Delay feedback label. Delay mix label. Delay dry label and delay wet label. Okay, those are those. So we should have some labels down here. Oh, they're over here. Why are they over there? Oh, it's column 0, that's why, isn't it? Critical span 2. This is going to be a 0. Silly me. Column 0. There we go. That's much better. So those are going to contain the data values. So let's pop back up again and find the sliders themselves. There's the sliders. We'll grab those sliders. Well, thank you very much. So here the sliders can go in here. So this is going to be the delay milliseconds. Delay feedback. Delay mix. Delay dry and delay wet. So that's those in place. They're going to need to be fiddled with a bit, but they're close enough for the moment. Okay, let's just go to this one. So a delay milliseconds. So what are we saying the values range for delay milliseconds is? 0 to 4,000 milliseconds. Okay, so 0 to 4,000. Delay feedback we said was between 0. Delay between 0 and 0.95 because we don't want to push it over towards 1 any closer than that because we will get the feedback. Angry little hamster. Why use labels versus text blocks? I don't know. Angry little hamster. I'm not a WPF programmer, so I'm just doing the best I can with it. The object of the exercise isn't the GUI anyway. It's the synthesizer part of it. But yep, it's only because that's the way I've picked up since I started about 2-3 weeks ago on WPF. So I'm still learning XAML, still learning all things we can do. They could indeed be text blocks. So no particular reason, Angry. Sorry, it's not a particularly satisfactory answer, I know, but it's just the way it is. Really, it's just because that's what I've been using. And then we want some labels again, don't we? So we can pinch these labels, and they might actually be correct. So yeah, if you're a WPF developer, Angry, then that's by all means chime in with this kind of content because yeah, I'm a back-end developer, so I very rarely allow myself to get anywhere near doing front ends. Yeah, I think text box would work, but yeah, because what you could do if it was a text block, I guess you could have it so you could input the values as numerically with the numeric keypad, rather than you just using the slider as the only control. The reason why I didn't go for that is that it's supposed to be like, you know, a synth where you have analog controls. But yeah, you certainly could do it that way. So that's going to be feedback. We're going to need to make these bigger. This is that needs to be a capital M. This is going to be mix. So I need to go and find that what I've misspelt. That down here. Mix label. Because that'll only cause me problems later on. Then we've got dry and wet. Okay, so let's fiddle with these labels. So that one needs to move across. So let's take that 15, maybe 20. Yeah. So feedback can come back now. Maybe that's 0, and it needs to be slightly wider. I think we need to move that slider across a bit. Then mix looks okay. Dry and wet look fine. They're not that well spaced out, but that's okay. So let's look at this one here. This is the mix. We can move that across to 40. No, that's the wrong one. What's that? 30. Feedback we want, so make that 40. Yeah, and then we can knock that to 20. So those look okay, and then these labels here. Those ones look okay. That one is the one that's out, so the feedback. So if you make that 15, see what that looks like. Okay. So now we have to go to our T4 template, which is going to generate all that, wire that up for us. So let's add those in. So these are going to be label properties. Okay, so we've got, they're all going to be floats to begin with, and well, no, they're not all floats. One's an int, isn't it? So the first one is the delay. That's an int, and that's going to be called delay milliseconds. And that's simply delay milliseconds. Milliseconds, and we no need to int it. Well, on front end, such an amazing skill. I agree. When I do front ends, they are usually what a developer would do. They're not the nicely designed things that other people do. I'm just not very good at it. We got some gain here, haven't we? So the best thing we'll let's do a calculator. So log to the base 10 of oops, I didn't put, so 0 0.95 log to the base 10 times 20 minus that's not right. That's what should be right. 0.95 log to the base 10 times. Never right, is it? I suppose it is actually, isn't it? Minus 0.4 0.45 0.45. Okay, we'll think about that. I'll just make a note that's the decibel value. Garage Coder, thank you for the follow. Lovely. Thank you very much. Let's give you some Electric Alf to celebrate. Here's Electric Alf celebrating that you're now following. So thank you so much. That's really, really kind of you. We're kind of bumping up towards our 200 follower goal. So thank you. I'm always amazed when people follow. So it's very, very kind of you. Okay, so what I'm on here. I think I've just killed off the bot. Let's start the bot up again. Okay. Okay. So here we are. So this is going to be feedback, delay feedback. This is going to be delay feedback times 100. That's going to be percentage. Make all these percentages now for just to make it simpler to start with. Then we can fiddle around with them later. I'm slightly concerned about the feedback one, making sure we have the right value ranges for that. So then we get a delay mix. Delay dry and delay wet, and then we can copy these across. And this needs to be the same as this. There we go. Oops. And do some OCD stuff to tidy this up. So Angry, what's the LP class? So this is a labeled property. So we run our template. Okay, let's see what happens. Oh, I've got the cricket scores. Well done. So where's my unexpected property? Delay mix. Okay. I think I've got too many of those. There we go. Generate that again. Let's see what happens now. So did that cricket score include the World Cup? It did, didn't it? Okay, so Bangladesh won. Wow. Okay. Okay, so we got our values. This is too short now. We need to increase that. So we got That's all wired up nicely, that looks okay. And we've got the percentage needs to come across a bit. Those percentages need to just be sorted out on their range. Okay, let's do that. And we need to move the feedback across, but make it smaller. So at its height, it's going to be 94%, 95. We want it really, don't we? Okay. So let's sort out the GUI parts so we don't have to worry about those in future. Over to here. This one wanted to come across. That's the feedback label. It can probably be a lot narrower. Let's make it 40 and it can come across to 25. That looks a bit better. Okay, and then we got our ranges are all wrong, aren't they? So this should be 1 to 0, and that should be 1 to 0. And that's 90. Let's make it that. Try again. And we need to make the actual whole synthesizer window larger. So that looks a bit weird, but it's okay once we're into decent ranges. That one looks okay. That one could use to come across a touch. As could that one. As could that one. They're not bad. It's not dissimilar to the way position of those. Okay, so we'll live with that. So we need to make the whole window a little bit bigger. Maybe 1000 was the right value. Let's try that. Yes, the T4 templates all Fuel Snabel's wonderful invention, and it's fantastic. It really saves me having to worry about a lot of this kind of wiring up of the GUI components, because the GUI component part is not what we're trying to focus on. When we come to doing the C++ side of it, we've got a framework to use there as well, which makes that it makes it a lot easier for me to handle the wiring up of the various parameters controlled by sliders and knobs and things like that. So I'm looking forward to that. This could do with being a bit smaller. It's a bit too big now. So let's make that 950. See what that looks like. Yeah, that's fine. We could do with it. We need to kind of label this as being the delay, don't we? But let's not worry about that just now. Okay, so that's wired up to that. So now we can close those out. We can go back to our view model. In fact, we can go to our delay sample provider, and we can lose these default values, but we'll copy them and then lose them. And then over here we can set them up in the constructor. Where is the constructor gone? This class is getting a bit large, but never mind, we'll cope. And this has got to be delay milliseconds, delay feedback. Delay wet. Delay dry. And in fact, we want our milliseconds to be 0. We don't want any delay effect initially. Okay, so now we need our property changed events. Okay, so let's get an instance of our chorus, our delay, in here. So private, this is going to be a delay sample provider, underscore delay. Okay, and then we can come down here. Let's copy them into here. Okay, so this is, we need to, let's not be so rash as to copy them all so quickly. We need to make sure that our control is there. So if underscore delay is not equal to null, then we're going to do something. It's going to be underscore delay dot delay milliseconds is going to be equal to current. Okay, you're going to go away, red squiggly. Oh right, this is supposed to be delay milliseconds. Okay, you can go away now. Thank you. Right, let's put the rest of the values in. So this is going to be delay feedback. This is going to be feedback. And this is going to be delay mix. This is going to be mix. This is going to be delay dry. This is going to be output dry. And then we're going to have delay wet. And this is going to be wet. Come on, thank you. Because they're not doubles there. This is an int. Oh, I think the rest were floats. Like that. Let's go back to our template. What did I create them as? Floats. So what's wrong with that then? No defined equation found to implement interpretation. Float. They should be. So I've obviously misspelt them. I'm nice. So let's go back over here. So we've got delay feedback. Delay feedback. There we go. And then these are floats. Yeah, these signatures were. Yeah, I just got the signatures wrong there. Feel stable. Look at it. So it comes out to be reasonably obvious in the end, because I make the same mistakes all the time. So that should go away now. Yeah. Let's build and make sure that's happy. Yep, it is. Okay, so now we should be in control of those parameters. So let's introduce a delay into our sample signal chain. So we'll put it after the chorus. So we want to say delay. So this bit is just like plugging your guitar effects one into the other. So we just make a chain of them, and we're going to pass the phaser into that, and then we're going to pass the delay into the low pass filter, which I'm debating whether we actually need the low pass filter in that position, but it's not doing any harm at the moment. So that's actually wired up now. So let's see if it has any effect. Switch on. Okay, so we've got our defaults are set, but our delay is 0, so we shouldn't have any delay. Let's play the note A. Let's introduce, I don't know, are we just blown up? Why are we just blown up? Interesting. Is it a certain number, or is it any number above 0? Yeah, it's any number at all. So our delay position's gone negative, isn't it? Yeah, delay position's negative. So why is that? It started off at 300 milliseconds. Let's default it to 300 and see if it still blows up, because that's what it started off as. Oops. Um, 300 on the project. John, we're blowing up straight away. So why is it blowing up? So our delay sum provider takes that's a double. It's 0 to 4000, which is what we set the range to, I believe. Delay 0 to 4000. I wonder if it's because it's null, isn't it? I think that's the problem. So let's, it's null. I think, is that the problem? Is it null at that point? Let's have a look. No, we've got null protection in there, haven't we? Let's pop a breakpoint there. Is that back to 0? Okay, let's step into that. Delay position is not, is that delay position is not initialized? Is that the problem? Delay position. Delay position is 0. Why is delay position? Or is it that? question is, why is it a float? I guess is a good question. We're changing it to an int. So it's 21 there. It's wrapped. It's this into conversion, isn't it? It's turned it into a massively negative number. I wonder why it's that number at all. Okay, this is interesting. So we're recalculating on set slide. So let's pop a breakpoint in set slide. And we'll remove that breakpoint. Start up. Set slide's probably the thing that's at fault here. So delay length is 0. Delay length is going to be the result of that, which is still 0. It's because I haven't set. So what's the values? They position set slide. So if I go off into set slide again. That was the feedback. 0.6. Delay length. Mix. Delay wet. Delay dry. Okay. Continue. On. So we set slide. Delay length is 0 when we go into there. After that function, its delay length is that 926. So we've got that. Breakpoint here. Okay, so the delay position is infinity at that point because we're dividing by 0. Wonderful. Yeah, that's the problem. Delay resample position. Division by 0. We got infinity though. We didn't get division by 0 error. delay resample position. So what we're going to do initially, we're going to turn resampling off and just see if we can get anything to come out, any sound to come out of this plugin, out of this effect. Pardon me. So we're getting an echo. Okay, so maybe we need to I need to revisit the resampling algorithm. A lot of reverb, a lot of echo on that. We need to reduce the feedback. If it's 4 seconds of that's ridiculous. For 400 milliseconds is quite long, isn't it? I think 4,000 milliseconds is way too long. That's some silly delay. Yeah, I think we're going to reduce that. So 4,000 is far too long. So let's fiddle with that for a start. So over here, so the delay, we're going to go to I don't know, 1,000 milliseconds is probably long enough. But see, that's quite a long time, a long delay. Resample, so we're dividing by 0. Why are we dividing by 0? I wonder why is that happening? What can I do to prevent it dividing by 0? Do I just simply need to, so it's dividing by the sample rate there and there. So let's just put some basic protection in there. Let's say that's not equal to 0, then that 0.0, else then simply delay position. Let's pop that up in there as well. Put the resampling flag back to true. Don't necessarily need the resampling, but we'll give it a go, see what happens. So fuel stable, not everyone agrees with what? Oh, use of partial functions. Yeah. What? It's all right. Bang. We're doing division again somewhere, are we? How interesting. So we've exceeded the 500,000, or was it 500,000? I wonder why it's doing that. If the delay is less than delay length, which it is, and resampling is true, then resample position is 0.97. The delay resample position. Resample position is. Why is that? Resample position 9. Angry Little Hamster, thank you very much for the follow. Let's have some Electric Elf to celebrate. Thank you so much. Oops, we've got some music going as well. Let's switch that off. That's my MIDI keyboard wire hitting the stream deck. Thank you very much, Angry. That's really, really kind of you. And Weetol, welcome to the stream. Good to see you. So we're kind of struggling with a bit of a weird resample position. Should be set to that. I'm going to take this off stream. I think we're going to just switch the resampling off in the algorithm, and then I'll need to investigate that. Because it's one of those ones I've got to kind of sit down and work out why it's exceeding the bounds that way, and why the algorithm has got me using floats. The algorithm might have fooled me into doing the wrong thing with that, making that delay position a float. Yeah. Okay, but we can now get an echo. So let's try and go the whole hog with. We need to label this up, but let's leave that as very sharp attack. We'll have I don't know, a middling delay, a long closes down. The volume goes right down to sustain, but it's a long sustain. We're going to into there, and then we're going to have some echo. So 300 milliseconds of echo. And then voice 2, sine wave, once again very quick attack, slightly longer delay, staying right down here, long release. We're going to have +1 octave, and we'll put it's about -6 decibels. Then voice 3, once again, with these a bit. Falls away quite sharply, long delay, long release rather. 2 octaves above. We'll have some vibrato, and we'll have some chorus. And this should be really bell-like. Bit ethereal. Let's get the old MIDI keyboard going. So MIDI on. Yeah, it's quite a good the level on third voice. I think that was oh, didn't I bring the level up? Okay, let's bring the level up to I don't know, minus 12 decibels. Let's see. Oh yes, more ring to it now, isn't there? Let's have some ring modulation as well. Let's put the get some amplitude modulation going. 400. Let's lower the octave. Octave up it. So it's sounding pretty good, isn't it, really? So we can really kind of mess with that by throwing some more synthy sounds into it, like some sawtooth waves into it, and a bit of, I don't know, a bit of square wave into it. So let's change the envelope. So let's play with it like that. Let's make it a saw wave. We've now got touch sensitivity on our MIDI keyboard, so. And yeah, how hard I hit the keys. So let's get rid of some of this echo. Get rid of that. And we're getting some really synthy sound is going in the background now. That chirping that's going on is really going to say synthy. So let's bump up the level. See if we can get more of that. And then I don't know what else. Yeah, let's lower this release over here. Yeah, I like that. That's good. And then we can make that a sawtooth as well. And I guess we can remove some of this chorus and have some phasing instead. Get the feedback in there. That's a bit weird sounding. Let's bring these right down. So we're getting plenty of different sounds out of this now, aren't we? So and we can experiment with a lot more of those kinds of sounds. One of the things I want to do in one of the next streams is to actually be able to save some of these settings. So once we find a nice sound, we can actually save it away and store it on disk and then bring it back. Vito, what's that comment about? Luskart's games nostalgia? Is that a television thing or something, or is it a computer program, computer game? Does that recognise the reference? Okay, so we've wired that up. We've got ourselves a bit of an enigma with this resampling algorithm that's blowing up with dividing by too big a number. Yeah, it's interesting that. I wonder why it's doing that. LucasArts gaming develop is a game developer company thing. Okay. Oh, LucasArts. Oh, okay. So I read that completely wrong. Yes, it said Day of the Tentacle and all that kind of stuff. That was LucasArts, wasn't it? Lots of 8-bit stuff. We've actually had the synthesizer sounding, like church organs. It's not all kind of jangly, kind of 8-bit type sound. So, I guess it depends what kind of other processing we put on there. For example, we could put those low pass filters on there, just to take out some of that the high frequencies and mellow it down a bit. I want to do a bit more with filters, the high pass, band pass, and when we do the equalizer, the graphic equalizer, having the band pass filters in there. But I actually want to do some work on filters first in as plugins for Reaper, VST plugins using Juice. So I'll learn a bit more about what filters do in the background, because they're relatively complex things. The book that I've got on designing audio effects, it kind of lists 30 different filters. So and mathematical equations that govern them are relatively complicated. So I need to do quite a lot of work on to understand what those are all about. Okay, so let's go over to our. We don't want that. We want here. Implement the echo delay. So we've done that now. So wired up. Delay. Milliseconds. Feedback. Mix. Wet and dry to GUI. Not feedback. We'll close that. But we're going to immediately open a new issue. That's going to be delay effect. Delay effect. Exceeds array limit when resampling is enabled. And that was inset slide. Inset slide methods. Okay, submit new issue. Okay. So what else have we got here? Relative low pass filters. That's something we can do. So this is the idea of relative low pass filters is to put low pass filters which have got a variable cutoff frequency against each note. So, for example, that you put a low pass filter which cuts off 4 octaves above the note you're playing, and we'll see if that kind of brightens the note at all. No, the array limit I've got. It was the actual the length of my array was 500,000, and it got bigger than that. I think that's what it was doing, because it was divided by a very small number, rather than being infinity, which we prevented when we was divided by 0. We're still dividing by a very small number and getting a number that's bigger than 500,000. So that's what I mean by that. what I'll do is I'll make that clear. There we go. We haven't done the flanger yet. We want to be able to create patches and record patches. Loops and sequences. Anyone wants to help me with loops and sequences, please fork the project and submit PR for that. Graphic equalizer. I think Link Stumps was going to work on that. I don't know if he is. Why do I have such an array? It's the delay array, so that's where all the echoes go into Retail. So when we have that echo, it probably do a bit smaller because it was set up to have a 4,000 millisecond maximum delay, but that was like you press the key and you can go back and make lunch and come back and it was still echoing. So we cut that down now to what a 1 second maximum echo delay. So that's why it's such a large. But you got to remember that the array size for a sample for each kind of 1 second of audio is 44,100 samples. So it's a large number because it was dealing with quite a large number of possible echoes. So we can probably fiddle with that, but I'll have to look through the algorithm and try and figure out why we're dividing by a small number at that point. Because I'm pretty sure we should be taking the inches of parts of some of these things and not. See, it's all they're floats, and the algorithm called for floats, and I'm going to go back and examine the algorithm because maybe I've mistranscribed them because I don't understand why I was getting that issue. Because before I wired it up to the GUI, I wasn't getting that issue. When the resampling was on and the delay was 300 milliseconds, it just worked anyway. That's right. It's a queue. It's a place where you put the delays in. Yeah, that's basically what it is. Okay. What's the time? It's 25 to 12 my side. So I think that's probably as much as we're going to get done. I didn't get to look at Juice. I will show you Juice briefly. So let's close some of these things down here. I'm going to before I forget, I'm going to push what we've done up to GitHub. So let's go and have a look at that. Changes. This is episode 41. So those are the changes we're going to commit. Bearing in mind there is a bug in there, but it's not an apparent bug at the moment because we've disabled that part of the algorithm, the resampling. I'm tempted to just rip all that part out anyway because it sounds pretty good without resampling. Let's commit that and sync it to GitHub. Okay, so that should be available for you to download, play with, do whatever you wish. It's all open source. You're completely free to do whatever you want with that code. But if I'm inspired to contribute, please do so. Fuel Snable's already he's contributed to about 5 PRs already, so it'd be great if somebody else can get involved as well and try and move this project forward. So it's quite fun to be able to make the sounds out of your computer, isn't it? It's one of the first things we probably all did with our computers when we first got them. Well, certainly when we were hobby computers back in the 70s and 80s, making sounds out of your computer was kind of one of the first things you did. So that's that. I can get rid of this. So so we can have a look at Juice. So I'll just show you briefly. So Juice. Okay, so it's a C++ framework which can be used to develop cross-platform GUI applications and audio applications. It's completely cross-platform. It's Windows, Linux, Mac OS, iOS, Android, all those kind of platforms. And it's really quite an interesting thing. Now it's going to take quite a while to get your head around it. So I'll just show you what it is. So when you start up the application, you get these are the different kinds of projects you can create. So obviously there's a GUI application, there's application with animations, OpenGL, console, audio plugin, and then the static or dynamic libraries you can create. So you can create an audio plugin, for example, and I've created one here, which is called VST Test. You can link it up to whichever development environment you want. What we're going to call it, let's open an existing project, shall we? Let's go back. Open existing project. We're going to go to dev juice, that one. Okay, so what it basically does, it gives you some a framework to work in. So you get in this case, this is a plugin for digital audio software. You get an editor class and a processor class and a whole bunch of modules that come with it. With these, you can configure a lot of the parameters which this plugin is going to work in. So we'll give it a name, company name, my website, the type of plugin it's going to be, what formats it covers, and it forms a large number of different plugin formats, whether it's a synthesizer, this is a MIDI plugin, loads of things like that. And then basically what you do is click on that button that launches Visual Studio, and then you can start coding. Like I say, this is my this is the plugin I created as a test, and you get loads and loads of boilerplate code to basically you can fill in the gaps. Now a lot of it's reasonably complicated until you get your head around it, and I haven't got my head completely around it yet. But basically, what you do with this then is when you compile this up, there's a GUI component to it. So there's a slider in this case, which is a GUI kind of component, and then separate from that is the actual plugin that does the processing. This is a MIDI volume control. So basically, what we're doing here is just basically it's not what I wanted to show you. It's here. We're just multiplying the we're replacing the MIDI volume in the MIDI message, which we looked at earlier, the velocity, with a new velocity based upon the slider value. And if you want to see what that actually looks like when we actually use it, if I bring up Reaper, and we wait for it to count down the evaluation license. So if I bring in a virtual instrument, if I bring in a synthesizer, okay, so that's a synth, and then I bring in bring my FX in, which is going to be my Codebase Alpha test plugin, and I move that above my synth. So now what happens when I press on the MIDI keyboard, the values are going to go through my plugin into the synthesizer. Currently the MIDI volume, this is my kind of very poor GUI which I've got, just a basic slider with a pop-up. At the moment I'm pressing the keys. You can see here I'm pressing the keys on my keyboard, and my MIDI keyboard, that is, and nothing's happening because the sound's right down, but I can bring this up. And the reason why we got a disconnect, see, as I move this around, nothing's happening to the volume, is that I'm using fairly crude way of connecting the slider up to the actual parameters of the DAW, the Reaper DAW. So we need to kind of sort that out. But it was only just to see if I could get a plugin to build, really. So what I'd like to do on a future stream is to kind of build a new plugin. Maybe we'll have a stereo left-right channel controller to start off with, and then start to build some audio effects in this environment, rather than just in the C# toy synthesizer environment. Because this is this isn't it's a synthesizer, but it's a very basic one. But what happens? You add all the effects underneath and chain them together. So this is basically something which creates tones, creates sine waves or whatever. So that's Juice. I think it looks quite interesting, and you can do an awful lot with it. All these different kind of applications, and there is actually some demos. So here's the demo, and this is all cross-platform C++. So fucking GUI, I don't know. Looks quite nice kind of stuff, you know. Graphics demo, grid demo, images. Not sure what that is. The web browser, which crashes because it's got some scripts on it. What else is there? DSP, utilities, multi-threading, JavaScript demo, cryptography. Quite a lot of stuff. That's a light pad. No, can't do that one. But the GUI had some interesting things on it. Widgets, Windows. Multi-document interface. Doesn't appear to be working. Transforms. Yeah, so it looks interesting framework to play around with. So I thought I'd learn a bit of C++ and have a play with that. But we need to kind of work out, what to do with it really. Okay, so I think I'm going to try and find someone to raid. Let's go over to Twitch and let's see what's going down over there. Have we got anyone we can... Is the Michael Jolly on? Scoot's on both of it. Let's go and raid Scoot, because he's doing some DAW work, I believe. He's writing a custom DAW in JavaScript, I believe. So let's go over to Scoot. Do stay with the stream if you wish to follow the raid. Otherwise, I'll see you on Wednesday when we do some more synthesizer work. So thank you very much for joining the stream today. Very kind of those people who followed. Thank you everyone who joined. It's been interesting, and I'm hoping that this project is of interest to people out there as well. So let's raid Scoot and see what he's up to. So take care everyone, and I'll see you Wednesday.